Okay, so here we go. So I'm really pleased to introduce Jordan Powell. He's a developer experience engineer at Cypress, which you may have heard of. He's passionate about writing good code, whatever the hell that is, I dare say, that's easy to read, test, and maintain over time. He's over a decade experience in software development, marketing, design, and video production. He serves as a CEO and co-founder for the nonprofit Dream On Global, which you might tell us a bit more about. When he's not working, he spends his time as a husband, father, and Cleveland sports fan. Which sport is that? Is that football?
All of them, really. Football, basketball, and baseball. But
okay,
or American football, I should clarify. Yes.
So Jordan's going to talk about component testing with Cypress. So Jordan, over to you, mate.
Awesome. Well, thank you guys for having me. I'm gonna still screen share for a second, and hopefully, oops, not that. Hopefully everyone can see my screen. But yeah, so today I'm going to give a talk on component testing with Cypress. And like our host mentioned, I am Jordan Powell. I'm a developer experience engineer at Cypress, and you can follow me online, LinkedIn, Twitter. My handle is at JordanPowell88. And oops. Okay, and so today, basically, I broke the talk down into like 4 parts. One is going to be like how to like testing components, like the step back. Let's think about how we test components. Going to second part, talk about how testing components impacts the way we build our components. And then part 3, we're going to talk about like how you can then use Cypress to basically do parts 1 and 2. And then in part 4, I'm going to kind of show like how we can do all 3 of those steps. So the first thing to start off with is why component testing. And I think it's always really valuable question to ask why when we're talking technology. You know, today it's what seems like infinite number of solutions, technologies to pick from, all those types of things. And I think that asking the question why, like why should I care about this thing? Why should I care about this technology, this, because at the end of the day, like there are so many things to choose from, and it's important to understand the problems you're solving and why you should care about something. So first, I want to start with like why component testing, like why is it important? And the way I would like to say it is, when we used to build applications, we used to think of it from in terms of pages, and in some ways we still do this, but we used to really focus when we build applications. Like I need a home page, I need an about page, I need a products page, maybe a products detail page, and so forth. And we would basically write applications with like under this constraint of like we would put all of our page code in like a single file or something like that, and we would kind of build our applications this way. But really, today our applications are more like this. They look much more smaller, and the reason why is we think of our application not just as a page, but as like a bunch of components, maybe tens, maybe dozens, maybe hundreds of components in a single page. And there's reasons for this, and the main reason is this idea of what I would like to call like component-driven development. And we've kind of gotten this to this place because of the acceleration and adoption of component-driven development frameworks like React, Angular, Vue, and others that have really kind of went all in on this idea of our applications are not pages, they're comprised of like a lot of little tiny components. And that adoption on those frameworks, the adoption by those frameworks and the number of developers who are using those frameworks has really made this as like the de facto way we develop and think about our applications. The other thing is that we now live in a world that's very it's very distributed. We have autonomous teams. We have teams in different time zones. You all, or at least maybe not all of you all, but most of you are in like the UK. I'm in America. I'm, I don't know, like 6 hours behind you guys. So we're working on teams that are distributed throughout the entire world. And we need a way to work on similar things, maybe the same thing in a distributed way. So component driven development really enables us to do that much easier. We also need more scalable and decoupled code. We are writing and releasing features faster than we ever have. And so we need a way to write code that's more scalable. We can get it out the door faster. And the way we do that is by making code that's less decoupled from other parts of our application. And that's where components end up being sort of like boxes or buckets, or sort of like a boundary that says this component lives here and all the logic lives inside of here, and I can move this around anywhere, and that component and its behaviors still remain the same no matter where it's at. Then reuse and consistency, like I just hinted at, is that we need to be able to not only just breaking our application into components to make it smaller and more scalable and decoupled, we also may find we build something like a button or maybe an input, but that button could be used like in maybe multiple places on a single page, most likely multiple places throughout our entire application. And in a lot of cases now, not just our team, our application, our product, but across multiple products, multiple teams, multiple different deployed applications. So reuse and consistency is become really, really valuable. So that same button, if you want to make changes to it, instead of going and copying CSS across all those different places, we just change that component one place and you get the same reuse and consistency and all. Finally, like improved maintainability. Obviously, the faster we're releasing code, the more we want to push out features, and we want to test them to make sure that they are reliable. Components really help with making our code more maintainable in that way. So I like to think about, let's shift gears a little bit and talk about, I like to think about testing in the form of like real life things that we sometimes like maybe relate to better. And so for the sake of this, we're going to talk about cars. I'm not a car guy, I'll admittedly say, but I think it's a good place to kind of draw the analogy. And so for the sake of this, cars look like this, right? But they're comprised of lots of different parts. We have engines, and those engines have parts inside of it, and we have tires, and we have lots of different parts. Again, not a car guy, so my limited scope of the parts of a car are don't go as extent as maybe a mechanic or something like that, but you get the point that a car is comprised of lots of parts, and those parts have lots of units like nuts and bolts and tiny little things that serve one specific purpose, but they're very valuable to representing those parts to make sure they're safe and they're reliable. And so if we think about a car, like how would we go about testing a car? Well, I don't know about you, but if I went out and I bought a car today, I would want to make sure that it had been tested, that it drives, that it's safe, that I'm not going to put my wife or my kids in it and it's going to be dangerous. I think we all want to be safe, and I think we could see the value in testing in this example. So how we would typically do this this is an example of a more like end-to-end type of test where we're testing a high level. We would want to like validate that the car drives. So we would like we would get the key, we would then turn the key, we would get the transmission, put it into drive, we would press the gas pedal, we would turn the wheel to the left, turn the wheel to the right, we'd push the brake pedal, we'd put the transmission in park, and then we'd be like, okay, we've done all the kind of core fundamental things that a car does. And obviously we can go way more in detail and depth, but this just gives you an idea of the type of an end-to-end test for this type of scenario. So basically that when I drive away from, a car lot, I know that hey, I can drive this car. I know the gas pedal works. I know the steering wheel works. I know it stops. I know the transmission works. All the core fundamental parts of a car work. But we also would probably want to make sure that the individual like pieces of the car worked right too. So we would do like a unit test where we'd say, I want to validate that the bolt works correct or something like that. And so we would do like a unit test, which would basically test a specific part of the bolt of every single bolt or something like that. So this is the one that's a little more difficult to maybe conceptualize in our brain, but essentially you want to make sure that the bolts that hold your engine together are not breaking, that they're strong, that they actually aren't going to cause problems to other parts of your car and ultimately your safety. So those are the types of tests that we've traditionally done, and we do like integration tests and other things. But for the most part, like this is kind of example of the type of test we would write. And so kind of summarizes, we have tests that would test all those little tiny units, that the parts work right. And then we have sort of like this test that makes sure like we can drive our car. But like what happens if our radiator goes out or like a part of our car like that? Well, if we instead of thinking about think of it as a bunch of parts. If we take a part out of our car, all the other tests per se for all those other units will work. Now the radiator we know is broken, but all the other parts will probably still pass in our test scenario, as well as we'll actually still be able to drive the car. We may not be able to drive it really long, but eventually, the car is going to slow down and, overheat. But you get the idea of like a end-to-end test would not catch a radiator initially broken, because we would say, oh, it drives. We can turn it to the left. We can turn it to the right. We can brake. We can turn it off, and oh, we're good. Ship the feature, right? It's all good. You can buy this car, even though the radiator is bad. So again, and the other thing is it still looks like a car. So we could test it and we'd say like, oh, like it looks like a car and I can drive it. Like I trust that the salesman didn't pull a fast one on me too much anyways. So I feel like, okay, like I feel pretty confident about this car. But the problem is like it could very easily turn into my mower, which this is a picture of that I sit in my garage for several years because it's broken and I can't get it to start and I haven't taken the time to get it fixed. So let's think about what we kind of talked about in terms of the sort of testing pyramid. I'm sure many of you have heard of this, but in a testing type group of people. But the idea of just to kind of re-highlight it, but the idea is like what we were just talking about, an end-to-end test where we're just testing to make sure the car drives. That would historically kind of be at the top of our testing pyramid. We would have lots of unit tests that would test the individual nuts and bolts of our project, and then we'd have maybe some integration tests that kind of test the how multiple parts of the radiator talks with other parts of our project or of our car. But it doesn't, like, where do components like sit in this? Because we normally have just kind of thought of components as like a unit. So we have like a unit, and this is how we would test that. And then we have integration tests. It's like testing the way two units integrate between each other. And then an end-to-end test, which tests kind of how all of the units and all the parts work together from kind of start to finish. And if we go back, we already talked about our apps are comprised of components. So like, what is a component? And if we want to step back, if we think about like, what is a component, let's put it in a box. Like a component, we already said, is kind of like a box that we can then move around. But that box is comprised of something like a class. If it's like Angular or like Vue or something like that, there's like an actual JavaScript class that it's using. React uses like a function. It can use a class as well, but you get the idea of like, there's some type of notion of a class. And then that class would have a template, which basically helps do binding of values between the class and the template. And then that class would most likely have different types of services that it would inject that then basically get passed down to the template. And then that component most likely has children, maybe one, maybe more. And so like what we would normally do is we would unit test the class, right? We would unit test all the different public methods and properties to make sure like those things work right. And we basically would mock out our template. We would mock out, this integration here. And because we'd say, well, I kind of trust that works. And then we'd mock out this here. We would, instead of actually passing the real service, we'd create like a double or like a spy or a mock or something that basically represents the service, but isn't an exact real copy of the service. And so like, really, like, what is this? Do we just end-to-end test this thing? It's very difficult when we look at how complex a component actually is, even though it can seem small in our brains and we have lots of them throughout our application. When you really uncover it, it's much more difficult than that. But like, that's like a kind of like a more like higher level component, something that does logic. But like, we also have something known as like presentation components, or like what I call like a dumb component. So like, even in those instances, we have our box that still has a class. A dumb component has a class, even if there's no logic in it. And that class still has a template that it binds, that has HTML, has HTML that it represents. And then and it also has CSS that gets bound into the template, and it makes that HTML style certain ways and look different ways. So again, like, what we would do is we would just basically create like a unit test to make sure we can kind of like new up this class. And then we basically create an integration here, and we kind of do an integration here. And then we're back to like, we're not like that type of test really provides like not much value. Like, so then do we just like end-to-end test? And so the idea is like, on a pyramid, like, what is a component? And it really doesn't fit into a pigeonhole of how we think about components. So the idea of like, I like to do it like this, is component testing is kind of like unit testing. It's kind of like an integration test because it's like testing the integration between multiple parts, but we test it not like a unit test or an integration test. We test it like an end-to-end test. And so, because we want to make sure that the component not only logically works, but we want to make sure that our user's interaction with that component is consistent and works as expected. So that's where component testing comes into play. And that's where I like to do a circle, because it's not, doesn't fit into the quote unquote like box, but it just kind of shows you it's kind of all of them, but also like none of them at the same time. So in this case, what we really want to do, if we step back, is we want to be able to take all the parts of a component and we want to put it inside of a test. We want to test the entire thing without any like mocks or integrations. We just want to basically take this entire thing and basically make it look like this. We want to test it. We don't want to test the code. We want to test the component as it's going to live in the wild, in production, when you ship this thing. And so that's what component testing does in Cypress. So again, like, why component testing? Component testing gives you form of documentation. Every test you write becomes documentation inherently, not the direct reason why we would write testing or do testing, but it provides documentation. You get this very isolated effect, which I'll talk about more in a minute. But you're working with one component at a time in isolation, so you don't have to test things in relationship with other components and parts. Testing gives you confidence, which is, the reason as developers we want to ship code that we feel confident in. And ultimately, we want to improve our user experience because those are the people that buy our products, give us money, and make sure that we still have jobs, which is important. The other idea is we want to think about testing in this idea of shifting left. So like this is the sort of diagram we would use to build software. Historically, we'd gather system requirements, software requirements. We'd basically form some type of analysis. We'd turn that analysis and data into like a program design. We would then take that design, begin coding, and then we'd be like, hey, we should probably like test this thing before we ship it to production. Which that's kind of the typical way we would build software over the years. And what we want to encourage people to do is shift left and basically take testing and move it as far left and up this diagram as possible. So that way, excuse me, so that way we can begin to think about testing in every step of this process. And the earlier you identify, the sooner you start thinking about testing, the more likely it is you're going to identify problems that you would eventually run into at the latter stages of this this process, and will hopefully save you time and money and frustration sooner rather than later. So the other thing I want to talk about is test-driven development, which component testing is a big advocate for. I personally am a fan of test-driven development, but I think it's oftentimes when you have a given set of requirements, test-driven development is an excellent way to go about developing, but we oftentimes don't have the known requirements as detailed as we need. So test-driven development can become difficult. Excuse me. So basically, like, let's take a look at this component. How would we go about building, if we were working on making changes to that component in our application? What we would do is we would go and we would serve our application. We would basically run Webpack or compile it and put it on a dev server, and we would run this locally. And then we would go to our code and make changes, find that component and make changes to it, which is fine in cases where we just have like one page. We can just navigate to the thing we care about, but it's still like we only really care about this. We don't necessarily need to see everything else, and it can become distracting. If you're like me, you easily get distracted. So being able to having to develop this in the context of everything else can sometimes get distracted, and I see other problems. I want to go fix those problems, and it can become very unproductive. Excuse me. The other thing is, I would say, is if we look at what happens if we have more complex data diagrams where we have a user flow where you have to go from one page to the next page, filling out forms to get to the final page that you care about. And I've been there working on forms. We have to fill out multiple pages of forms to get to the final page. You can update the thank you button or the thank you message or something very trivial, but takes forever to test and takes forever to work on as a developer. That's where what we really care about, again, is we just care about this component. So component testing eliminates that burden, and it makes the process of building our components much better. So I'm going to kind of fly through this part real quick. Cypress, basically, before it, testing end-to-end, or basically browser testing, was very, very painful, and it went about it very, very differently. Cypress basically took a bunch of decisions that you had to make, and then you had to keep those all in. You had to make sure all those things work together and stayed up to date. And Cypress basically said, we want to take care of all that, and we want to, our motto is we want to make a test runner that's built for humans. And so you get time traveling, debuggability, read-time reloads, automatic waiting, which I'm not going to be able to go into in detail, but it's a huge part of what makes Cypress a great. Spies, clocks, and stubs, as well as screenshots and videos. So anytime a test fails, you get an actual recording of that. You get a screenshot of what the DOM looked like. So these are just some of the things you get out of the box with Cypress. And so, and it also works runs in all of these browsers. So Chrome, Firefox, Edge, Brave, and we now have support for WebKit, so you can do Safari testing as well. We historically, when we go back to that pyramid, Cypress always represented end-to-end testing, which we talked about here, where component testing are basically, end-to-end testing can be anything that runs in a browser. So if you can run it in a browser, you can end-to-end test it with Cypress. Component testing, though, is different. Though it does run in the browser, it's tied to a framework. End-to-end testing doesn't care. It just says, hey, if it runs in a browser, I can read it. It doesn't, because at that point, your components and your application code gets compiled down to vanilla JavaScript and HTML and CSS and shipped in the browser. Component testing is different because it runs on a dev server and it's tied to the specific implementation of your application. So we have support for React, Angular, Vue, Svelte, and we have additional community support that is being added to some additional frameworks as well. The mounting, how you mount them is very similar across the frameworks. And in React, you just pass in, or in all of them, we have a mount function. So you just do side.mount, and in like Angular or Vue, you can pass in like the class name. In React, you can pass it JSX. And if you're using JSX and Vue, you can do that as well. That's what it looks like. More detailed with React. You can see here, same thing with Angular using the class syntax, and same thing with Vue using the class syntax. So again, if we go back to this car example, what happens if our radiator goes bad? What we want to be able to do is, in the case of if we think of a radiator like a component, again, we want to make sure we can test our radiator to make sure that it, when we put a radiator in, it operates and works exactly the way we expect it. So that way, not only does it work in isolation, but when we put it in scope of our entire car, that it works with all the other parts as well. So we basically want to take this radiator and put it in here. So now we have, instead of a bunch of kind of unit testing all of our parts that are not adding a lot of value because we end up mocking a lot of individual parts, we add component tests for all the parts of our application or of our car, and we end-to-end test to make sure we can still drive it, because that's still very valuable. So I'm not sure how I got like 5-10 minutes left, I think, but I'm gonna just do a quick demo, because I think being able to see is going to be like, see component testing is going to be valuable to everyone, because it's one of those things, like once you see it, you're like, ah, that makes sense. Let me pull out of this. Okay, I got just under like 10 minutes. Perfect. So let me share. I'm going to have a big screen, so I'm going to draw a box in here. Perfect. So you should be able to see my screen now. Let me move this over here, move this over here. And so I'm using NX. So there's a generator that runs this, but basically you just launch Cypress is all I'm doing. And what it's doing here is it's going to pick up the browsers that my application, that my computer has. I'm going to tell it, which one I want to use. In my case, I'll use Chrome. Let's say I want to start using component testing. And then by default, it's going to look for any test that I have. And so at the moment, I just have 2. And let me click on this button, for example. Well, this button test is really simple that I have set up. It basically just mounts a component, nothing else in it. And then if we go back, we have an input button, which does a little bit more things. And it says, hello, friends. Like, it's basically, these are the types of things we would do in end-to-end testing, but we would do that in a stage, in in the context of like an entire page. Well, here we're literally just like mounting the component, and we're we're interacting with it. With here, like I can also like, hello, my friends from the UK. Like I can still interact with this. I can still see the styles, which is a really, really valuable part of component testing. Is if you're unit testing these things, you don't get to see the way these look in the browser. You don't get to see how they actually interact because you're just running it in a terminal. So if we go back, like let's look at how we're writing these tests. So in this case, let me zoom in so hopefully you guys can see good. But what I want to get at is here's this button component, and again, it's very, very simple. I'm just side mounting this button component. This component, the test is going to live right next to my component. Here's my component has an input, and it also has an output. So when you click on it, whatever parent component, the parent component that adds this can basically do whatever it wants to. We also have, here's the template, and this is Angular, so I'm using like content projection, so you could put something inside of here. So it's like say something. So in this case, if we wanted to like pass, like display text, like if we notice right now, it's not displaying anything. It's just a button. It doesn't have anything in it. It looks just like a pill. It's not really looks like a button. So, and the way we know that it's displaying whatever's inside of the button, but like, how would we go about doing this? Well, there's a couple ways we could do it. We could like create a component in Angular, and we could like, make a selector and call it like my button. And then basically we could my class and call it like a wrapper component and do something like this. Excuse me. It's gonna yell at me because it wants me to. This is a conference I was just at that I was doing this demo at, so I'm gonna do this. And so there's a couple of things we could do. Is then inside of this template, we could create like a we could actually create a template that basically uses this the button component itself, which is like but basically you would like mount this component in here. So you would do something like this, and you would do like Caribbean, you would do this, but it'd be like, instead of my button, it'd be like this. And you would then do like, hello friends, or something like this. So you could do this, and instead of then mounting the button component, you would then mount this component. And you could do something like this, but this is like really not a good example. It's really trivial, and who wants to do all that just to test something? So we also allow you in React, this is really, really simple because it's just JSX and you pass it in. But for the sake of components in Angular, what we want to do is we want to do the button component. And let's see, let's just undo this. Okay. And I don't care about this anymore. I don't care about this anymore. So now I still have a button that's passing, but I can also go to this, and I can just reference this like HTML inside of my test. So I can also do it like this, and I can say, hello friends, something like this. And the only caveat here is there's a second optional thing here where I need to then declare the name of this button, because I'm passing a string and not the actual implementation. So I need to do this. And so now if I run this, it's going to say hello friends. The other thing is, if you noticed, has an input and output. So if I want to, I can write a test, or I can add to this test. There's there's an option to pass in component properties, and it's going to give me the type of properties, which in this case, if I change it back, because we're not having any typing because we're doing it this way. So if I change it back to button component, and we don't want this to be a string, you'll now see we get typing. So now it's going to tell me that I can pass in a position, or we can do the click. So in this case, I want to do position, and I can pick center, start, or end. So in this case, I want to do start. And so instead of, or it's already in the middle. So, or at the start, let me do, what was the other one? Center. Let me do center. So now I do this, and now it should mount it in the center of my screen. So this gives you an idea of how you can write certain tests. The final thing is, instead of updating the position, if we want to basically, like, every button you're going to click, right? So we want to be able to click on it. So click in Angular is an event emitter. So it has a function called emit. And what I'm going to do is pass a Cypress spy, and I'm going to give basically this spy an alias. I'm going to give it a name and call it, I'm going to call it clicked spy. And so because I changed the type of this, I just need to cast this to any, which isn't ideal, and I'll show you better ways around this. But the idea is, if I then go get, and this is a button, so I can just get the button and I can click it, I can then get the alias using this @ symbol and say clicked spy. Whoops, if I can type, and then I could say should have been called. So I can then verify that this has been called. But let me not click this and go ahead and click this so you can see it failing. So now it never got clicked. You could see it's failing. If I then add this, you add click, you'll now see it is clicking the button, and you validate that the button was actually clicked. So this is kind of just an example of how you can use component testing in a super fast, high level way. But I guess at this point, maybe is a good time to answer questions. I have some examples of, I can add some example repos of how you do this with different frameworks, but I think for the most part, I'm not sure the audience is, the persona, if it's more QA people, if it's more developers that are into testing, or maybe you're neither one of those. But I think hopefully this gives some insight into component testing and how just a better way to test components with Cypress component testing. So
fantastic. Thanks, Jordan, very much indeed. Yeah, we've got a couple of minutes. If you can post to the audience, that is, can you post questions through Slido? I don't know if I've seen a question on Slido for some time now. I don't know if people are in difficulty with it. But anyway, so going back to earlier in the talk, Jordan, to me, integration is like the biggest challenge we've got with functional testing. And even when you're doing component level or even TDD, and you're looking at an individual function or feature, setting aside the issue of whether you have subcomponents or other objects you want to call, all that kind of stuff, and we have to substitute with mocks and stubs and all that kind of stuff. Is what you're calling component testing a mechanism for dealing with some back-end code, HTML, style sheets, React, or one of the other frameworks? I mean, there's an integration at that level, isn't there? And is that what you think Cypress is really at the foremost? I mean, I know you didn't have time to do a proper end-to-end soup to nuts demonstration, of course. What do you think?
Yeah, so I mean, obviously, like, Cypress's bread and butter has been end-to-end testing. I mean, we have like 4.5 million downloads a week of Cypress. Like, it's wildly popular, right? So it's like the de facto end-to-end. There are others out there, but the thing that really separates it is the fact that it like actually runs in a browser, which I think is something that we should really not undervalue. Like, there's a lot of value in that problem. But the thing we noticed is like what happens is you used to never write end-to-end tests because they were so painful to do. And so, but when Cypress came, it actually became easy to test, and you realize you were getting so much value from them. So then we end up writing all these end-to-end tests, which, not that I'm saying it doesn't replace end-to-end testing, but there are things that we really want to do an end-to-end test at a very micro level, like a component, because our apps are comprised of components. So the problem with how we would sort of solve this problem before is we would basically unit test or do some type of like testing like that, but we would end up those types of tests were very difficult to do. So we would basically create all these like spies that are like all these mocking all this data. And then you end up not even testing the real thing. You're testing like fake data. For example, like with component testing, like how you would unit test like a Redux store or something like that is you would pass in like a fake implementation of the data of the store, and then you would like, click a button that then dispatches an action, but you don't have any like, you basically, you're like, after the action is dispatched, I just trust that it works. Where it's like with component testing, you actually import the actual store itself. So that way you're actually testing the code that's going to be shipped in production in an actual browser, the way your actual users are going to interact with it. So instead of just testing that when you click a button that an action gets dispatched, which is not that valuable if you really think about it, you're testing, okay, you could test that it got dispatched, but you could also test that the response, that the change that happens in the DOM actually is reflected as a result of all of that. So it's like really like an end-to-end test in the scope of a component. So you have
kind of visibility of stuff that normally is invisible to the end user. Well, it's always invisible to the end user, but you know you need to get into it, and maybe that's where Cypress fills that gap. I've got to close it down there, old friend. Thank you so much, Jordan, for the talk, and I hope to speak to you soon.
Yeah, absolutely. Thanks for having me, guys.
Yeah, take care. Good luck in Ohio.